Here, they might stand for cohesive intermediate categories like cabbage-like, savory fruits, squashes and gourds, greens, fungi, and roots and tubers, each with a set of input weights that allow it to pick out the corresponding stereotype, and strong weights to vegetable in the output layer. The challenge in getting these networks to work is how to train them. The problem is with the connections from the input layer to the hidden layer, since the units are hidden from the environment, their guesses cannot be matched against correct values supplied by the teacher. But a breakthrough in the 1980s, the error backpropagation learning algorithm cracked, let's just do it again. But a breakthrough in the 1980s, the error backpropagation learning algorithm cracked the problem. First, the mismatch between each output unit's guess and the correct answer is used to tweak the weights of the hidden to output connections in the top layer, just like in the simple networks. Then, the sum of all these errors is propagated backwards to each hidden unit to tweak the input to hidden connections in the middle layer. It sounds like it could never work, but with millions of training examples, the two layers of connections settle into values that allow the network to sort the sheep from the goats. Just as amazingly, the hidden units can spontaneously discover abstract categories like fungi and roots and tubers, if that's what helps them with the classifying. But more often, the hidden units don't stand for anything we have names for. They implement whichever complex formulas get the job done. A teensy bit of this feature, but not too much of that feature, unless there's really a lot of this other feature. In the second decade of the 21st century, computer power skyrocketed with the development of graphics processing units, and data got bigger and bigger as millions of users uploaded text and images to the web. Computer scientists could put multi-layer networks on megavitamins, giving them 2, 15, even 1,000 hidden layers, and training them on billions or even trillions of examples. The networks are called deep learning systems because of the number of layers between the input and the output. They're not deep in the sense of understanding anything. These networks are powering the great AI awakening we are living through, which is giving us the first serviceable products for speech and image recognition, question answering, translation, and other human-like feats. Deep learning networks often outperform GOFI, good old-fashioned artificial intelligence, which executes logic-like deductions on hand-coded propositions and rules. The contrast in the way they work is stark. Unlike logical inference, the inner workings of a neural network are inscrutable. Most of the millions of hidden units don't stand for any coherent concept that we can make sense of, and the computer scientists who train them can't explain how they arrive at any particular answer. That is why many technology critics fear that as AI systems are entrusted with decisions about the fates of people, they could perpetuate biases that no one can identify and uproot. Oh, wow. Oh, wow. Oh, wow. I haven't been super concerned about people's concern that we're just going to put in our biases into the AI systems. One, because we're going to be using sort of the best of our thinking to program them. But of course, this is deep learning. And because I don't really know about this stuff, I can't really say anything. In fact, often when I talk about humans being programmed, it's wrong because that would be GOFI, the way that I talk about the its. I don't talk enough about these layers I don't talk at all. I mean, I didn't know. Or, no, anyway. Okay. Um, hmm. Okay. I take back some of the things I've just said. But that's so interesting that there would be new biases. There would be different sort of shortcuts that don't actually work, but that are selected by the training. But if there's so much training, how are you? Because the problem with humans is that the shortcuts that we evolved with, one, we couldn't change them very easily, and we didn't get a whole lot of experiences. So sometimes there would be a shortcut that only gets used a few times in your life. The second thing is that even if that shortcut was wrong, like avoid that area because there are predators, it's not that like big of a deal for that to be wrong. And then also there, yeah, and there was thirdly there was no testing for it. So one, there was no testing. Two, there's no correction. Two, there wasn't a um. Anyway, the things I just said. So those are some major different. Those are some reasons why biases exist, or why unreliable it's persevere in human mental systems, but you would think would be able to be corrected through deep learning. For humans, we just don't learn. We don't learn like these machines. We're just, all right. In 2018, Henry Kissinger warned that since deep learning systems don't work on propositions we can examine and justify, they portend the end of the Enlightenment. That is a stretch, but the contrast between logic and neural computation is clear. Yes, it is. Yes, it is. Yes, it is. Okay. And I need to take that more into account in my thinking and explanations. All right. Convinced. Is the human brain a big deep learning Is the human brain a big deep learning network? Certainly not. What? Certainly not, for many reasons, but the similarities are illuminating. Okay? The brain has around 100 billion neurons connected by 100 trillion synapses, and by the time we are 18, we have been absorbing examples from our environment for more than 300 million waking seconds. So we are prepared to do a lot of pattern matching and associating just like these networks. The networks are tailor-made for the fuzzy family resemblance categories that make up so much of our conceptual repertoire. Neural networks, thus, provide clues about the portion of human cognition that is rational, but not technically speaking logical. They demystify the inarticulate yet sometimes uncanny mental power we call intuition, instinct, inklings, gut feelings, and the sixth sense. I got you. So this was a semantic issue for me. All right, so yeah, so we're not logical. I still don't like using the word rational with all that it means to people. You can't just be like, oh, by the way, rational and logical are slightly different. Expect people to just understand that. And then you even put technically, whatever. For all the For all the convenience that Siri and Google Translate bring to our lives, we must not think that neural networks have made logic obsolete. These systems, driven by fuzzy associations and incapable of part are and these systems, driven by fuzzy associations and incapable of parsing syntax or consulting rules, can be stunningly stupid. If you ask Google for fast food restaurants near me that are not McDonald's, it will give you a list of all of the McDonald's within a 50-mile radius. Ask Siri, did George Washington use a computer? And she will direct you to a computer reconstruction of George Washington's face and the computing system services of George Washington University. The vision modules that someday will drive our cars are today apt to confuse road signs with refrigerators and overturned vehicles with punching bags, fire boats, and bobsleds. Human rationality is a hybrid system. The brain contains pattern associators that soak up family resemblances and aggregate large numbers of statistical clues. But it also contains a logical symbol manipulator that can assemble concepts into propositions and draw out their implications. Okay, yeah. Yeah, it has. Yeah, okay. I wouldn't count on it a whole lot, but yeah. Call it system two, or recursive cognition, or rule based reasoning. Recursive cognition, I like. System two is good too, because it's, yeah, and the system two, it's engage with the system one, it's, and that's what makes it recursive. Rule based reasoning, no, I do not like that. But I would like if you said that in this recursive cognition, there were its that sort of represented the rules and played a role, like in the images, in the neural network images, played a role in the other cognitive mechs. But I wouldn't want to say that the reasoning comes from the rules. There are a lot of other elements voting as well. Formal logic is a tool that can purify. All right, so let's put check, check, and Yoda. Rule based. We'll put on the word based. Formal logic is a tool that can purify and extend this mode of thinking, freeing it from the bugs that come with being a social and emotional animal. God, you fuck up so much though.